I'm Chris Sharma, Financial Services Sector Lead at Canonical. I have with me Pedro Cruz, who is a Technical Product Lead. We're joining you live from United Kingdom. Having spent more than 20 years in the industry in various leadership roles, the one challenge every organization faces is how to reduce IT cost while delivering more business value and innovation. We will address this topic in this session and present a case study on how enterprises can automate software operations to reduce their IT spend on keeping the lights on, thus having more IT budget for transformation programs. The FS industry is in the middle of a perfect storm. The macroeconomic conditions are shifting. Customer expectations are rising. Regulatory landscape is constantly changing. Financial institutions are having to adapt to the rapid change and are in a catch-up mode to innovate and deliver new services to customers. As we very well know, the application landscape at financial institutions is complex. How organizations plan and manage the underlying challenges of aging technology infrastructure, the overhead of software operations, and integration impacts the success of large simplification, modernization, or digital transformation programs. In this presentation, the focus is on software operations. 20. We are all familiar with the Pareto principle, the 80-20 rule, and the uneven distribution of inputs and the outcomes. In the context of IT change budgets for financial institutions, only 20% of change budget is left for technology modernization. Here is a typical average change portfolio breakdown at financial institutions. As you can see, 80% of the budget is spent on either mandatory change, process reengineering, and various revenue growth initiatives. This draws our attention to the fact that firms need to reduce their IT total cost of ownership. But how? Typically, the IT spend at enterprises can be categorized into 4 areas: hardware and facilities, software licenses and services, software operations and maintenance, which is a major chunk of IT spend, and the remaining budget is spent on innovation and change programs. Financial institutions are able to significantly reduce their total cost of ownership by automating software operations and maintenance. That leaves more budget for innovation and change. So what do we wish from software ops? We want software operations to be simple, reliable, and expected to work every time seamlessly. Just like our trusted kettle that provides us with a hot cup of water every single time with a flick of a button. But the reality is software operations are costly, they're complex, they're messy. Enterprise software operations are messy because traditionally, operations code have been handcrafted by every organization for a particular application for their own use. Every new piece of software requires an in-depth understanding of that new application by the operations team in order to deploy and integrate that new application component effectively into the IT landscape. Now, with ever more new pieces of software to integrate from various open source publishers, with ever faster releases, there are too many configuration files with too many permutation and combinations to keep track of. It becomes extremely challenging to find the skills needed to integrate and maintain the application stack. There are several day-end operational challenges, including software maintenance, the lifecycle management, software integration, and service orchestration, all of which leads to a higher TCO. A recent report by the Linux Foundation and the Lab for Innovation Science at Harvard highlights that the open source constitutes 80% of any given piece of modern software. So the question we asked ourselves, can open source address software operation challenges? Unleash the power of open source and the open source community. When application code is open source, why not share the operations code too? Open source community has the power to dramatically reduce costs and improve the working lives of DevOps engineers. What is needed is to transform operations code from a homegrown artifact into open source packages that can be published, consumed, shared, updated, just like the apps on your phone and packages in Linux. They're not templates, but production-grade operation code that works everywhere. Imagine a world where you don't need to tweak every script or configuration file to get your scenario to deploy, scale, upgrade properly. Because those operations are already handled for you in the code, which created by you and the community around you. So let's look at a financial services case study on how open source community and open source tools can address software operation challenges. Legend. Legend is a data modeling platform that was contributed by Goldman Sachs to the FinTech Open Source Foundation. Legend is an environment, it's a platform with wide utility across pricing, risk, and various other business functions within a financial institution. Based on the various use cases identified during the pilot, it was clear that the financial services industry is ready for collaboration and using open source data modeling tools. Now, there are various ways to deploy this enterprise application, but each approach results in considerable time and resources being spent on installation and configuration. So why is that so? Even at a high level, one can quickly realize that the application is composed of many components that needs to be deployed, it needs to be configured, and those application components needs to be integrated for the environment to be set up successfully. Legend as a platform allows financial institutions to build data-driven applications and insightful business intelligence dashboards. One of the application components of Legend platform is called Legend Studio, which is the visual data modeling environment that is used to design, build, and test models in an intuitive, business-friendly way. Now, behind the scenes, Legend is backed by a powerful execution engine and uses GitLab for the software development lifecycle. Now, this enables users to leverage their data model in the business workflows while ensuring that the data models are safe to use in live business processes. So imagine deploying this enterprise-grade application, which is composed of various application components, with one single command that sets up the entire environment and then also integrates the various application components. Yes, now you can do that with open source tool, Juju, with a single command, which brings down the application deployment and the environment setup time from days and hours to just a few minutes. And single command is Juju deploy FINOS Legend bundle. So what are the ingredients that make this happen? 2, charmed operators and Juju. If you were able to make it to the earlier talks in the day, you must be familiar with Juju and charmed operators. For those of you who couldn't make it to the earlier sessions, charmed operator, an operator is a design pattern popular in Kubernetes environment. Charmed operator, packaged as a charm, encapsulates a single application code and know-how it takes to operate that application. Charmed operators implement and automate not only the day one tasks, which is installation, configuration, but then also automates the day two tasks like update, backup, failover, restore, reconfiguration. The goal of Charmed Operator is to put operational knowledge into software, which previously that knowledge resided in the minds of administrators. The other ingredient is Juju. Juju is an open source tool. It's an operator lifecycle manager that automates not only the application deployment, but integrates the application and manages and automates the day-to-day operations for your entire application stack. Juju is cloud vendor agnostic, and the application workloads can be deployed across public clouds, private clouds, and is hybrid multi-cloud ready. So let us have a look at the demo now. Over to you, Pedro.
Thank you, Chris, and thank you everyone watching this. So we've actually put together a demo. We recorded a video thinking that the demo would take too long to deploy, but actually the engineers working on this managed to deploy the whole Legend stack in just 6 minutes. So the video is just for making sure that we are able to run everything properly. So you can watch that now. All right, so the first command we're running there is Juju status, and that shows that there's nothing in that computer at the moment. And then Juju clouds will show that Juju already identified a microcates and LXD instance in that computer. And then we're running Juju Bootstrap on microcates. And what that means is that we're actually putting a piece of Juju, a Juju controller inside the cloud. And that Juju controller will later handle the deployment and the management and the communication of the application with the Charmed Operator. And then we're running the Juju Ad Module. And a module in Juju is the equivalent of a namespace in Kubernetes, and it's a very important concept in Juju. It sets the boundaries of your deployment, of where you're thinking about deploying. Once the module is created, we can actually deploy the application. And here we're deploying the Legend bundle that we've created. That will create the infrastructure that you need in your cluster, and also install the applications. And again, not only install, but run all the code and any configuration needed to leave these applications ready in standby mode. Let's put it this way. Ready to perform whatever they were programmed to perform. You see some applications here will be blocked, and that means that they're waiting for some information from other Charmed operators or an external service. In this case, they're waiting for a token from GitLab. So that's what we're going to do now. We're going to create an application in GitLab, and then get this token and pass it to our stack, our Legend stack. All right, and first of all, we just need to, before that, we just need to make a quick conversion there on the token. And one interesting thing here is that when you pass this token, you're not having to find on the 200th line of a YAML configuration file where to put this token. No, we just run a very elegant command, juju config, the name of your application, and then you pass the GitLab parameters. Once you do that, you can see the applications reacted to that. The Charmed operators reacted to this token. And now they're all active. And now we just need to authenticate a couple of these applications in this stack. So you just get the IP address of the pod there and access the authentication page. First, we are doing with the front end, which is Legend Studio, but we also need to do with the back end. So if we try to access the front end at the moment, you see authentication fail on the right bottom corner. And that's perfectly normal. The application was designed this way. All right. And then we perform a very similar authentication against GitLab with the backend. And once that's done, you have access to the user interface, which is the Studio front end, which is the front end of this stack. And there you go, you can create a modules and use application as you would use with any other installation method. So just talking a little bit of what is going on when you are deploying, when you're installing a charmed operator. So when you run the Juju deploy command, what you're actually doing, you're deploying two sidecar containers in your pod. One of them contains the workload, the application that you want to run, and the other one is a charm container that runs the charm code. When you're sending commands to your when you want your application to perform a certain task, you're going to send a command to the controller. The controller is going to send to the charm to the charm, and the charm is going to communicate with your workload container. In this way, keeping a charm container or workload container in the sidecar pattern. If you scale this, you always keep track of all your workloads, and everything is integrated in just one CLI. It goes through the controller and then to the Juju CLI. So how are we able to deploy all these things? So that's one simple command, the Juju Bootstrap command. When you run Juju Bootstrap, what you're actually doing is you're creating this logical layer of abstraction. There's no layer per se. It's not a hypervisor kind of thing, but it gives you the ability to deploy your applications or your charmed with charmed operators on any cloud that you wish. So you can deploy on the application layer. You can create your own operator, and that can be done with the SDK, or you can choose one of the hundreds of applications of charmed operators that are available at charmhub.io. And then let's talk a little bit about the Juju Ad Module. That's a very important concept in Juju, and I'm sure I'm not gonna make justice to the importance of this concept in this minute. But when you're adding a module, what you're doing is basically creating this whiteboard that sets the boundaries of that part of your deployment. So you can set the permissions, you can set the access control, and one very important aspect of that is repeatability. So when you create the module, you're also able to run. It's not exactly this command, but it's like take a snapshot of the module, and then you can replicate this. You can replicate a snapshot in whatever infrastructure, whatever substrate you have and you want to deploy it next. So what is actually going on there is we're deploying all these applications with the command Juju deploy, and if you have a large stack, you're going to run as many Juju deploy commands as you need to deploy each of your applications through the charmed operators. But what we are actually doing there is we created something called the bundle, and the bundle in Juju is something that will describe not only the applications that you're deploying, that you want to deploy, but also the integration between them. So that's a very interesting concept, because you can have 30 plus applications in one bundle, and the integration between them described, and all these things, they will run automatically in the sequence that you programmed or someone else, an expert program, and they will just run as they should with one single command, the Juju deploy command. And I think it's over to you, Chris, talking a little bit about the integration.
Thank you, Pedro. Integration. Now, integration code creates the most friction to upgrades and new components. Software integration, especially in the enterprises, in large enterprises, it's slow, it's hard, and then you're stuck with it. Legacy integration and operation code makes it difficult to drive change in the enterprise technology stack. Every change requires detailed consideration of the rippling consequences in custom operations code, most of which was not written by the current team. With Juju, on the other hand, you can integrate applications with one single command, Juju relate. Charmed operators expose the integration endpoints, and if the endpoints are compatible, you can integrate the applications. In the case of Legend platform, Legend Studio Charm requires a GitLab token, and GitLab Charm can provide the token. With a single command, the two applications are integrated and relevant information passed between the two application components. Single command, Juju relate FINOS Legend Studio, Legend GitLab. One can deploy application components or even applications across clouds and integrate them with Juju. For instance, in the case of Legend application, one can deploy Legend Studio on Amazon EKS, GitLab on MicroK8, MongoDB on another flavor of Kubernetes. With Juju, organizations can deploy their workloads and manage day-to operations in a truly hybrid multi-cloud environment. Model, cross-model relations, and model-driven operations give you the control to handle deployments and operations at scale across hybrid clouds, whether it's via CLI or in a visual tool such as Juju GUI or Juju as a service. So what we have seen is open source projects like Juju and Charms simplify integration and software operations. Save your team endless hours of script management. Deploy, integrate, manage applications across multiple K8s environments or VM environments. You can build complex environments frequently and manage not just the day zero, but the day two operations at scale. You can manage applications, you can manage services on the hybrid multi-cloud, and the bottom line is you minimize your operational costs. So take control of your applications, infrastructure, and environments. It's a step that's closer to the vision for software operations. Now it's your turn. Engage with us in discussions with the Juju and Charms community on Mattermost and Discord. Now here are the links. Try deploying FINOS Legend Charm if you would like to, or build your own charmed operator for applications that you're passionate about. That's from us. Thank you all for making time for this session. Any questions, we'll be happy to take the questions. We have got your email addresses here and the link to the Juju site, juju.is. And please visit the website for financial services, which is ubuntu.com/financial services.